Okay, let's see if this works. I am going to try to record the lesson as folks weren't here. This is not ideal, but it is a way to allow you to join this lesson even if you're not here or participating. So let's see how this works. I used to use a different program and I don't have access to that. So I can't do as many of the features. So we're just gonna have to see how this goes. So what we have is integrated math 1A. And this is my student dashboard. It says I am 0% complete and I am 3 activities off pace because we started by October. This was supposed to be done by October 7th. This is supposed to be done by yesterday. And now we are already on October 11th. So the first tutorial that I'm going to do is called Adding Monomials. I've already completed the tutorial, but I'm going to go back through it quickly so that way folks can play along at home. Now, these tutorials do not have guided notes. I will provide you with a teacher-created set of guided notes. However, because they're not available, we have to kind of create our own. So I highly recommend you going to Google Docs. If you don't know how to do that, you can open up a new tab and under your Google Apps icon is a document or Google Docs. You click on that and push the plus sign and create a new one. I suggest you title it Integrated Math Notes. The reason for that is so when you go looking through your Google Drive at your Google Docs, to find this, to use it on the test, you have it. So I already started listing the terms as I went through the tutorial. It's kind of out of step, but I also didn't consider recording this because earlier I had a student following along. So here we go. Let's get into it. So we do have some tools off to the side. We can take notes there. Not very handy because you can't use those notes on the test. So that's why I suggest putting your notes here. There's no resources here. There's not even a glossary. So we have to create our own. Following that, you have your there is a dictionary, so you can look up some terms, and there still are the reading tools. If you utilize those, keep using those. There is also a calculator, which can be helpful because it's really close, and I encourage you to use that. I also encourage you to go to calculatorsoup.com and use one of the many calculators that they have available. General math and algebra are probably going to be the most useful at this time. However, I use the fractions one a lot. Okay, let's continue. Adding monomials tutorial. I'm going to go ahead and let the slide narrator narrate so that way it speaks exactly what's on the screen. I don't add more to it, and we go from there.
You've probably learned about the prefixes mono, bi, and poly in language arts class. Learn how these prefixes apply to algebra.
So mono, like the monorail, binoculars, 2 lenses, monocular, single lens, and bicycle, 2. So mono being 1, bi being 2, and poly being many, like polygon.
In this activity, you will study how to add monomials. A monomial is an expression that has exactly one term. Each of the following expressions is a monomial.
So I've taken that, I've copied it, and I've pasted it into my notes. A monomial is an expression that has exactly one term. Uh-oh, what's an expression? An expression is like a saying. You're saying a thing. So if I give this long speech about don't play in the road, don't chase the ball in the road, don't run across the road without looking for cars. Instead, I would say the expression, look both ways before crossing the street. So an expression is a way of saying something. A monomial is a way of saying something with only one term. So let's continue. These are examples. I put that in my notes.
A binomial is an expression that has exactly two terms. Each of the following expressions is a binomial.
Term one, term two. Notice they are not the same. Term one, term two, they are the same, and there's two of them, two terms. One term added, then that makes two.
A monomial has...
I'm sorry.
Monomials and binomials are part of a larger group of expressions called polynomials. The prefix poly means many. Polynomials may be classified by the number of terms they contain. A monomial has...
I did it again, folks.
Polynomials that contain two terms are binomials. The prefix bi means two. Words like bicycle and binocular suggest two of something. A monomial has one term. A binomial has two terms. Here are a few questions for you to answer.
What is the following expression? So 3x squared plus 5. So is it a monomial, a binomial, or neither? If it was a polynomial, as in there were three terms or more, then you would put neither. So I notice that there is a term here and a term here. So there are two terms, binomial. Please click on answer and read these. It's super helpful to hear it again and to have it cemented. The expression 3x squared plus 5 has two terms. 3x squared is a term and 5 is a term. Expression with two terms are called binomials. It's supposed to be click to speech, but as you see, it's not necessarily doing it. So if that's the case, ask for help. What is the following expression? 4x cubed yz. Click on the correct answer. Is it a monomial, a binomial, or neither? Well, I don't see an addition or subtraction or anything else sign over here. I only see one group of things. I'm going to say it's a monomial. Great. Yes. Expression with one term are called monomials. A monomial is one term. A binomial is two terms. What is the following expression? I see a term, 3x squared, plus a term, z, plus yet another term, y squared. So it's not a monomial because there's more than one. It's not a binomial because there's more than two. Therefore, it is a polynomial. So I have to pick neither. Great. Here's the answer. The expression 3x squared plus z plus y squared has three terms. 3x squared, z, and y squared. Expressions with three terms are neither monomials nor monomials nor binomials. They're polynomials. Many. Okay. What is the following expression? 3x squared plus zy squared. It is a monomial. There are two terms. I think I clicked on it.
Here are a few
There we go.
questions for you to answer.
What is the numerical coefficient of this term? I had to look up and or pay attention. What is the numerical coefficient? Well, the only number I see, numerical means number, is -3 or -3. So in the box, I'm going to put -3 because it's just asking what is the numerical part. Correct. The numerical coefficient of -3z is the numerical factor -3. How would you write a term with a numerical coefficient of -5 and a variable of q? So this one is, how would you write the term? Not just identifying the coefficient, but the term. So if this was a math question, right, or this was a question on the mastery test, you need to know what a numerical coefficient is and what a variable is. So in your notes, add that. A coefficient or numerical coefficient is the number in the term. So I'm going to put -5q. Notice before I hit done that there are different tools here, and you can clear. You can add positive numbers, negative numbers, add or subtract or multiply. Notice that multiply is the little asterisk. It's a little dot rather than an X anymore. We're moving away from the X for multiplying, because when we're solving for X and it's next to an X for multiplication, that makes it confusing. Sometimes we can add monomials to simplify an expression.
Sometimes we can add monomials to simplify an expression. For example, the sum of 3x and 4x is the monomial 7x. We can write that expression as
7x. So what does it mean by simplify an expression? Well, when I was talking about walking across the street, playing in the street, looking for cars, I simplified that by saying, look both ways before crossing the street. Or don't play in the road. I simplified it. I made it easy. But the terms all were the same. Road, road, road. Don't play in the road. Look both ways in the road. Stay out of the road, that kind of a thing. So the terms have to be the same in order for you to simplify it. In this case, they were all X's.
Another way to solve the expression is to use what you know about numbers. 3x plus 4x is the same as 3 plus 4 times x. Now we can solve the expression by adding the coefficients. 3 plus 4 times x equals 7x. Therefore, 3x plus 4x equals 7x.
All right.
To simplify expressions with monomials, first check to see that the monomials have like terms. Like terms are terms that have the same variables raised to the same exponents. For example, the expression 3x plus 2y cannot be written as a monomial because the variables x and y are different. The expression 3x squared plus 2x cannot be written as a monomial because the exponents of the variables 2 and 1 are different.
Now, I copied that and put it in my notes. To simplify an expression, simplify expressions with monomials. First, check to see that the monomials have like terms. We cannot add apples to oranges. What do I mean by that? You can't add 3 apples and 3 oranges and make 6 apple oranges. You can't do that. You have 3 apples and 3 oranges. That's as simple as it can get. You can add 3 apples and 3 apples, though. So why do I put these in the notes? Because on the test, it might say, simplify this expression. I forget what it means to simplify the expression. I don't want to get the answer wrong because I'm not understanding the question. So make sure you understand the question and write things down that you do or don't know.
Now you try some.
Okay, so back to my notes. It said, check to see that the monomials have like terms. So this is a monomial because the terms are like, they're the same. So yes, they have like terms. That means I can add them together. So I break down the numerical coefficient, which is the 3 and the 3. I'm going to add them together because there's an addition sign. So 3 plus 3 is 6. The c squared stays the same, just like apples and apples would stay the same. You don't have to solve for whatever c squared plus c squared is. You just carry it over. So 3 plus 3 is 6, c squared. So 6 plus c squared. That is really close, but this is more correct. See, this says 6 plus c squared. This is 6 times c squared, which is what we get after we do the addition. So that's the correct answer. Again, you can click on show answer. And if the monomials have the same variable raised to the same exponent, this is the exponent. The 2 is the exponent. Simplify the expression by adding the coefficients. We did that. 3 plus 3 is 6. 6c squared. Okay, same thing. Negative 5b3 plus 8b3. The b3s are the same, so I can leave those. I can do this. Negative 5 plus 8, I could use a number line, or I can use calculator soup and go to general math, basic calculator, and do, what was that? 5 negative plus 8 equals 3. Negative 5 plus 8 equals 3. Then we have the B3. So 3b to the 3rd power. Correct. Yes. Negative 11y squared plus 9. Simplify that. Now, these two terms are not the same. I cannot add those together. Because I cannot add those together, this is as simple as it can be, which is the same. So I rewrite it the same. Correct answer. It says we cannot simplify expressions with monomials that do not have the same variable raised to the same exponent. The monomials negative 11y squared and 9y have different exponents, so they cannot be simplified.
Polynomials that contain only one term are called monomials. Sometimes monomials can be added to simplify an expression. To add monomials, add the coefficients of like terms. Like terms are terms that have the same variables raised to the same exponents.
I would copy that and put it in my notes. Okay, so they want us to do a few activities on our own. So this is done by first checking to see if you can simplify it. Are the terms the same? Yes, they are. They're like terms. Then I do the math. 15 plus negative 17. 15 plus 17 negative 17 equals -2. So -2. Now I got the u, but I need to do the exponent 8, not exponent 16. You just leave the term the same. So you leave that part the same. So u8. How do I get the 8 up there? I push this exponent button and then push 8. Notice how it is up there tall. If I do not do that, and I just put 8 there, it will say it's wrong. So I have to click on the exponent button and put the 8 in like that. And it explains it. 15 plus -17, u8. 15 minus 17, which is the same as saying plus -17, is -2, 8, u8. All right, 2a squared plus -12a squared. Can they be added together? A squared and a squared are the same and raised to the same power, so yes. If it couldn't be, then I would just type this in. So what is 2 plus -12 is 10. A, and then how do I get that exponent up there? I click on this right here in the middle where it says exponent, and then put that 2 up there and hit done. Oh no, the coefficient of a squared is wrong. Huh. A squared. All right, let me try again. So 2 plus -12 should be 10. Oh, it's -10. -10. A, and then I got to get that 2 up there. Exponent 2, or to the second power, done. So very important to watch your signs. Enter the original expression if it cannot be simplified. U to the 4th power, u to the 4th power. Okay, that can be done. 4 plus 27 is 31. U, and then exponent 4, done. Again, answer, check it out. 4 plus 27 u, 4 is 31 u4. Okay, -16a to the 4th plus 25a to the 4th. A to the 4th and a to the 4th are the same terms, so I can add them together. -16 plus 25. If you have a cell phone, you can say, hey Siri, what is -16 plus 25?
That would be 9.
So 9, and then a to the 4th power. Done. Great. Got it. Check answer. That's how it worked. Negative 16 plus 25. Might be able to do that in your head too. I don't like doing them in my head because I might get them wrong. Negative 20 W6 plus negative 14 W6. Are they the same term? Great answer. Yes, they are. So I can simplify that expression. I know that negative 20 plus negative 14 is going to be a lot more negative. 34. So I'm going to type in 34 W. Oops. I'm going to type in negative 34 W. 6 power. So I got an exponent 6. Done. Great. Check. Ready. Awesome. Enter the original expression if it cannot be simplified. 19W7 plus negative 26Z. Uh-oh. Z and W are not the same, so it cannot be simplified. So then I need to do 19W exponent 7 plus parentheses, might have to hit shift, and then minus 26. Uh-oh. Uh-oh. I apologize, I have to back up. So it's exponent 7. Notice that it is not up in the exponent section, so I have to highlight it and push that exponent button. Now it's up. It's raised up to the 7th power. Plus, oops. Okay, now my cursor was way up in the exponents. I want it down here. So now it's plus parentheses shift 9 is parentheses. Notice it put the closed ones there. Minus 26 Z. That looks the same to me. Hit done. Correct. We cannot find the sum of two monomials unless they have the same variables raised to the same power. Okay. Congratulations, we finished the tutorial. There are all of these activities at the end of this that you can do for extra support. So next I have the application, adding monomials. I'm going to go ahead and click play on that, and let's look at what it looks like. So while that's loading, I highly, highly recommend you to have a piece of paper and be able to write and doodle and draw and make notes, because that's how we're going to make sense of this. I like the speaky tool.
In this activity, you will practice adding monomials.
Monomials. Review. It's not letting it read. There is a way to do this. If you need it to read to you, you can copy it and paste it into an app called Natural Reader. I can show you that if you need help with that. Don't hesitate to ask. So polynomials that contain only one term are called monomials. Sometimes monomials can be added to simplify an expression. To add monomials, add the coefficients of like terms. Like terms are terms that have the same variable raised to the same exponents. Here's your chance to apply what you know. A set of questions follows. You have 2 tries to answer each question correctly. We'll keep track of your score. You'll earn 2 points for each correct answer on the first try and 1 point for each correct answer on the second try. In some cases, there is no second try. Dun, dun, dun. In life, you don't get a second quarter. That used to be a commercial. Click the forward arrow when you're ready to begin. All right, so we're going to simplify 4W9 plus negative 2W9. Are they like terms? Yes. What is 4 plus negative 2? That's right, it's 2. And then I need to make the W exponent 9, not 99, 9. Let's see, am I correct? Yes. And again, 4W9 plus negative 2W9 equals 4 minus 2W9, which is equal to 2W9. Simplify W3, W3. Okay, so we got W to the third power, W to the third power. What is 12 plus negative 26? I'm going to say that's 14 in my head. 14 W3. Uh-oh, I forgot to make it an exponent. I highlight it and push the exponent button. And notice it jumps up into the exponent position. Oh no, the coefficient of W3 is wrong. So the number in front is wrong. What's wrong about it? Double check. 11 plus negative 26. Uh-oh. Negative 14. Correct? Yep. Awesome. This explains it. Bada bing, bada boom. We got it. Okay. Next, simplify 2a plus 26a6. 2a6 plus 26a to the 6th power. Okay, 2 plus 26 is 28a and 6 power. Oh, I need to raise that up. I'm going to highlight it and push the exponent button. Now it's raised up. Done. Great. I simplified that expression. Now simplify minus 14b7 plus 3b7. So they're like terms. 14 plus 3 is 17b7. I got to make it exponentable. Oh no. I did it again. Uh-oh, negative 14 plus 3. Negative 14 plus 3. So I have 14, 13, 12, 11. So it should be minus 11. I got it correct that time. Okay, keep moving on. Oh, baby, here we go. Negative 22x6. Or x to the 6th plus 3x to the 6th. I'm going to say that is negative 19. Oops, wasn't clicking in the box. Negative 19 x and then exponent to the 6th power. Nice, here we go. You can't see this, but I'm using scratch paper to help me with these things that I can't do in my head quickly. 19z5 plus minus 3z5. The z5 and the z5 match. 19 plus negative 3. So 19 minus 3 is 16. So I'm going to put, and it's not negatives. Okay, negative 16z to the 5th power. Done. No, the coefficient is wrong. Oh, not negative. Dang it, buddy. There we go. Simplify 27u3 plus negative 25u3. u3 plus u3, or u3 and u3 are similar. They're the same type of term. 25 plus negative 25. Let me back up. 27u3 plus negative 25u3. So 27 minus 25 is 2u, and then exponent cubed, or to the third power. Nice, got it right that time. Okay, the original, oh, there we go. Enter the simplify negative 24b squared plus negative 23a. Are these terms the same? Is b squared and a by itself the same? No, they're not. So we cannot simplify that. Minus 24 squared plus parentheses minus 23a forgot the b right here. Okay, the answer is minus 24b squared plus minus 23a squared, or sorry, minus 23a. Notice I wrote that out because, oh, hold on. So it's saying no, and it's not letting me change it. So the b needs to be down here, not up there. That's where I messed up. Okay. All right. I got 11 out of 16. Outstanding. I'm going to save and exit, and in the recording, the next step is for me to do the mastery test. Use your notes on the mastery test. Best of luck. I'm going to come back and do the next one soon because we got to catch up. Okay. Bye.